Okay, the next thing we're going to do is we're just going to emphasize the signs of the trig functions as they're relevant in each quadrant. And we actually mentioned this when we did the unit circle. I think it was in section 4.2, but we're going to revisit it. In quadrant 1, all 6 trig functions are positive. So we're talking about where they are positive. Okay, and this one we said all students take calculus was our little reminder. And then that means the let me do it in blue. So the sine function and its reciprocal, okay, is positive. This is where they're positive. Okay, so then this one's tangent, and which one? Cotangent. Good. So if this one is cosine and secant. Good. So we remember this by all students take calculus. All right, so now we can ask questions kind of like this, like example 3. If tangent of theta is less than 0 and cosine of theta is greater than 0, which quadrant does the angle lie in? Okay, well, what exactly does this mean? Tangent is less than 0. That tells us that the tangent is negative. Good. It's the same thing we're saying the tangent is negative, and what's this tell us? Cosine is positive. So let's find the quadrant that satisfies that. Which one, first of all, which one is cosine positive in? Quadrant 4, right? Cosine's positive because these are the positive values. So cosine's positive here. Is tangent negative there? Yes. So we are in quadrant 4. Good. Now this is just if sine of theta is less than 0, it just means where is the sine value negative and the cosine value negative? What quadrant are sine and cosine both negative in? Well, they're positive here, cosine's positive here, so what's the only place both of them are negative? Good. Quadrant 3. So now we're going to extend that a little bit further and say we're given that the tangent of theta is negative 2/3 and they tell us cosine of theta is positive. Okay, find these two trig functions. So first of all, that just helps us to know where is our angle. Where is cosine positive? All students take calculus. Cosine is positive in quadrant 4. That's how I know I'm going to be in quadrant 4. Okay, tangent of theta, what's tangent going to be? Your y over your x value. Remember by your definition, so the y value, so this is like our y and this is our x. Our y value is, so we have a 2 over a 3. Now this is a negative fraction. One of these need to be negative. Which one does it make sense? Is the x value negative or is the y value? Good. Yeah, so knowing what quadrant in helps us to be able to label our sides of our triangle. So now that I have these two labeled, what can I do to find the missing side? Pythagorean theorem, or you can use your r equals the square root of x squared plus y squared by definition, but most people are most comfortable with Pythagorean theorem, so whatever works best for you. Okay, so I paused it and I did the Pythagorean theorem. Square root of 13 is our missing side. It only asks us specifically to find cosine of theta, and it asks us to find cosecant of theta. Okay, by definition, this one is x over r, and by definition, this one is going to be r over y. Okay, so the x value is 3. The radius is square root of 13. So let's just put it over here. So 3 over the square root of 13. What do we need to do with that? Let's rationalize that denominator. And we would just get 3 square root of 13 over 13. So cosine of theta Alright, and then let's do the same thing for cosecant of theta. What's the radius? Is square root of 13. The y value is going to be negative 2, so I just bring the negative out front. Okay, and that's all it asked. It didn't ask us to do all 6 trig functions, so those were the only 2 that we needed to do. Okay, hopefully you have the printout of this so it's printed out. And if not, pause it so you can write this down. But the definition of a reference angle. So now we're going to be practicing with a reference angle. The reference angle is the positive acute angle, acute meaning less than 90, formed by the terminal side, which is where the angle ends, and the x-axis. So basically our mindset is an angle less than 90 degrees closest to the x-axis. So, and I know you can't see these very well, but if the idea is that if this is my angle theta, okay, the closest way to get back to the x-axis would be this angle. Okay, it's the smallest angle, less than 90 degrees, that gets me back to this x-axis. Okay, and let me just highlight the x-axis because that's everything's going to be relative to that. Now, for example, in this next one, if this is my angle theta, the closest way to get back to the x-axis, would it be going in this direction or would it be going in this direction? Right, we need it to be less than 90, so we can see a reference angle for this case would be this angle, would be our reference angle. All right, let's look at a third situation. If this is angle theta, I need to get back to the x-axis. So would it be this particular angle here or would it be the one on this side? Which one's going to be less than 90? Good. So we have this one. So that's kind of the overlying idea. When I say what's a reference angle, we're looking for the angle theta that's less than 90 degrees that gets us back in reference to the x-axis. Okay. All right. So let's look at A. Let's see an example of this. Let me draw approximately where angle 160 is, and these are just rough approximations. So it's going to be somewhere over here. Okay, that's 160 degrees. My reference angle, which I'm going to call theta prime, would be this angle right here, which is the smallest angle that takes me back to the x-axis. Okay, now how do you think I could figure out what that angle needs to be? 180, because this is 180 degrees. So I would calculate 180 degrees and subtract 160 to find out what this red angle is going to be. So the reference angle, which is theta prime, is 20 degrees. Good. All right, let me draw a sketch of B. 345 degrees. That's like taking me all the way around, and I'm somewhere over here. Okay, what would be the reference angle back to the x-axis? I'd be taking it here or this small piece right here? Yes, of course, it's going to be this reference angle right there. So angle theta, how can I figure out angle theta this time? 360, because that would be 360 minus 345 to find out that the reference angle is 15 degrees. All right, let's talk about it in terms of radians. Using your unit circle, we can see that 5 pi 6, this may be hard to see, 5 pi 6 is over here in quadrant 2 somewhere, roughly. Okay, that's 5 pi 6. We want to know the reference angle, which is this right here. So instead of 180, what do we do? What's our radian equivalent of 180? Pi, right? So then we would say pi minus 5 pi over 6, which get a common denominator, then we would find out that theta prime, the reference angle, is just going to be pi 6. Okay. All right, and then now let's do D. So let's do a rough sketch. First of all, a negative 135. Remember, a negative angle, we go in the opposite direction. It puts us over here in quadrant 3. The reference angle would be a acute angle that takes us back to the x-axis would be that particular one in red. So how could we do that one? Instead of 180, let's use pi, because, oh no, we're going to use 180 because it's degrees. But this time we add good, so it's going to be negative 135. Oh wait, hold on a second. Okay, so back up 1 second. First of all, this is not on our unit circle, negative 135, so let's find coterminal to that so that we have a positive angle that is. Okay, what would be coterminal? In the same, remember coterminal means the same exact location. Yes, I would say negative 135, and I would first, let me come up here so I have some more room. Negative 135 plus 360 to find coterminal. I almost forgot about that real quick. So let's find coterminal. And really that's still going to be, what's that, 225 degrees? So we want to find the reference angle to that. So first of all, 225 is still over here. Okay, but we want coterminal, so we could take 225. Now we want our reference angle, 225. And then we want to subtract 180, right? Good. So now we just have angle theta, the theta prime, which is your reference angle, is going to be 45 degrees. Okay, so recall that if we have, oftentimes we will find a coterminal angle anytime we're given a chance to, and then find a reference angle. So we're going to do that some more. Let's practice some more of those.